Alright, so the question that you sent me about evaluating composite functions. When you're doing these type of problems, you kind of have to work your way inside out. So if you can see from this problem, it's giving you three functions. It's giving you f of n, h of t, and g of n. And when you're looking at this, it's clear that down here you see that 2 times f of n is in this function g of n. So you can see that f of n is equivalent to n, and that just means that you can replace this f of n with n. So g of n equals negative 2n squared minus n plus 2, and normally here you would put f of n as seen right here, but f of n is equivalent to n, so you can put n in that equation. Now the part that I'm sure is confusing to you is down here. It shows it wants you to evaluate the g of the f of negative 10. And that's the way that you should read these problems, is it wants to evaluate g of f of negative 10. And when you're doing these, you want to work your way inside out. So starting from the inside, you can see the inside function is to evaluate the function f for an input of negative 10. So if you go to function f right here, and you input negative 10 in place of the variable, which in this case is n, then you can see that f of n would just equal 10, because you're inputting 10 into that function. Therefore, you can now see that f of n is equivalent to 10 when you plug in, or I guess negative 10, my bad, negative 10, that's supposed to be a negative. So f of negative 10 equals negative 10. So now that you know that f of negative 10 equals negative 10, you can just insert that right into here because they're equivalent. So then that just simplifies this down to g of negative 10, because f of negative 10 is equivalent to negative 10. And just to review really quick, it asks you f of negative 10, because you always want to work your way inside out on these type of problems. So f of negative 10, you want to evaluate the function f at a value of negative 10. And we did that right here, and we see that f of negative 10 is equal to negative 10. Therefore, we can plug negative 10 in right here for f of negative 10, giving us g of negative 10. Because this whole value would just go to negative 10. And then this is asking you to evaluate g at negative 10. So to do that, you would just plug in negative 10 for all the variables n that you see in this g function right here. So just to show you how that would look, it would be, let's see here, g of negative 10 equals negative 2 times 10 squared minus negative 10 plus 2. And now you see that the 2 here is multiplied by f of n. And in this case, you're plugging in negative 10 for n, for your variable. Therefore, this is going to be 2 times f of negative 10. We already evaluated that right here. So we already know that f of negative 10, which it's showing you to do here, is going to be equal to negative 10. So you can add that in right there. 2 times negative 10. Now all that's left to do is to evaluate this function using a calculator, or if you want to try to do it in your head. So the take-home message of these type of problems is that you should always work your way inside out, because that's the way that's going to allow you to plug in the values on the inside of the parentheses, so you'll know what to plug in for the function g. So if, for example, it gave you g of f of h of negative 10, you would start by evaluating h of negative 10. Once you found out what that was by using this function, then you would be able to plug that in, and that would reduce down to g of f of whatever that value was. Let's just call it x for now. And then after you evaluate that function f for whatever value that we found from function h, then that would just simplify once again down to g of whatever that number would be. And then you could evaluate g for that variable.